All right, so in this lesson, we're going to be looking at multiplying polynomials. All right, so I'll explain what polynomials are later on in this lesson. But just to start off with here, what I'm going to do here is we're going to start with a fairly simple example that we should be able to work out, and then I'm going to kind of show you a trick when it applies to these polynomials. All right, so anyways, so this here, we want to evaluate 2 plus 3 in brackets times 4 plus 5 in another set of brackets. All right, so according to BEDMAS, what we need to do is you need to do the brackets first, right? So 2 plus 3 is 5, so that's the first set of brackets. 4 plus 5 is 9, the second set of brackets, okay? So if I multiply these together, 5 times 9 is 45, okay? So this is the way that you've been taught to solve these according to BEDMAS. Right? Now, what I want to do is actually show you a different way of actually getting this answer 45, and you'll see the connection when it comes to when we're multiplying polynomials. Right? So polynomials, actually, maybe I'll explain what they are right now. It's basically whenever you have, for example, like a number, a variable to a power, and then maybe I can have another, maybe add another same variable to maybe a lower power and so on. And so when you have this pattern, this is just an example of a polynomial, perhaps something like this, all right, where you have coefficient, variable, and exponent. All right, so you did see these actually in the previous unit when it was multiplying exponents and so on. All right, so this is an example of a polynomial. Basically, you have a number. This thing is called a coefficient. So these are coefficients. Then we have the variable, and then we have exponents. All right, so let's have that pattern. All right, so we are going to be multiplying these things, these algebraic terms, in this lesson. All right, now, in order to do that, what I want to do is actually show you a different way of getting this answer. So I'm just going to write it up again. So 2 plus 3 times 4 plus 5. Okay, so rather than working out the brackets and then multiplying, this is by far the quicker way. I just need to show you another property that also works. All right, so rather than multiplying or working out the brackets first and multiplying, what I'm going to do instead is I'm going to what we call distribute. So the 2 I'm going to multiply with the 4 and the 5, and then I'm going to multiply the 3 with the 4 and the 5. All right. So as a result, I'm going to have 2 times 4. Actually, I'm going to write that out. So 2 times 4. So that's the front, the first ones. And 2 times 5. So I'm going to add it to 2 times 5. And then 3 times 4, I'm going to add that one in. And then 3 times 5. Okay, so basically, yeah, I've multiplied, matched up these, the 2 with the 4 and the 5, and the 3 with the 4 and the 5. All right, so as a result, this is 8 plus 10 plus 12 plus 15. All right, so if I add these together, this is what, 18 plus 12 is 30, plus 15 is 45. So what you'll notice is, yeah, we do end up getting the same answer. However, this is just a different method. All right, so this is called, using red pen, this is called the distributive property. And when it comes to a what we'll call a 2 by 2, we're going to do something called we're going to FOIL. So FOIL stands for first, outside, inside, and last. So this is just a way of remembering to match up each one. Right? So first one here, we're going to multiply the first 2 terms together. Then we multiplied the outside one, so the 2 and the 5, and then the 3 and the 4 were the inside, and the 3 and the 5 were the last. Okay, so that's what the FOIL stands for, is this acronym: first, outside, inside, last. All right, so we have 4 items that we multiply together to get 45. All All right, so the reason I showed you this is because, if I get to this first example here, we want to expand and simplify. So these are polynomials, but what you'll notice is that 2x and plus the 7y, we can't actually combine these two together because they are not like terms, right? We have a variable of x here, and then we have a variable of y here. So we can't put these together and multiply, but if I wanted to expand and simplify, what it's asking you to do is apply the distributive property. So I'm going to multiply the first, then the outside, the inside, and the last. All right, so as a result, it's going to look like this. All right, so 2x times 3x is 2 times 3 is 6, but then x times x is x squared. Okay, so 2x times 3x is 6x squared. This is probably the only time I'll write out this in between step. All right, so it's 2x times 3x. So that's my first. Then I'm going to go 2x times negative y. So also make sure you include the sign, right? So the 2x and the negative y. So this is my outside terms. And to that, I'm going to add the inside, so 7y times 3x. Those were my inside terms, right? So inside of the 4. And then my last one here is going to be the last term. So 7y times negative y. All right, so those were my last. So first, outside, inside, last. So here I can now multiply these together. So 2 times 3 is 6. We have 6x squared. Next up, we have 2x times negative y, so that's negative 2xy. Then I have positive 7y times 3x, that's 21. That's 21 plus y. Right, so yx is the same as xy. And then 7y times negative y, which is negative 7y squared. Now, what you'll also notice here is that I'm not quite done. Right? I do have actually like terms. Right? So these two are like terms because it's negative 2xy plus 21xy. Right? So I have x to the first power, y to the first power in both of these. So these are like terms, which you learned about last year. So we can actually combine those two together. All right, so as a result, we get, again, the 6x squared, I'm just going to drop it down. So negative 2xy plus 21xy is positive 19xy. Just remember, you leave the variables the same, but then combine the coefficients. So negative 2 plus 21 is positive 19. And then I have the minus 7y squared. Okay, so this is now that set of brackets here expanded and simplified. All right, so cool. So first thing, yeah, so the main thing you want to remember is the FOIL. All right, so let's go on to the next one here. I have 4a minus 3b squared. All right, so this is a very common mistake, is to actually square this term and square this term. All right, so so you might see this 16a squared minus 9b squared. So that's a very common mistake, is to square both of these. All right, so this is actually incorrect. All right, so what you might have it confused with, just right on the side, is that if I have a monomial, so for example, so let's say for a b squared, all right, notice that there's no plus or minus. So these are all being multiplied together. So in this case, yes, this is going to equal 4 squared times a squared times b squared, right, which is 16a squared b squared. Okay, so this is fine. However, as soon as you get like a negative sign, then we can't actually just square this and square this, right? Square the two terms, because the negative sign separates these two to two separate terms, what they call it. All right? So what we want to do instead is whenever you see something being squared, you must write this out as 4ab minus 3b times 4ab minus 3b, right? Because the definition of squaring is to multiply the brackets with themselves, right? So as a result, what ends up happening is here we have, just like the previous example, we have two terms and two terms. So we actually have to FOIL or distribute this out. Right? So this is going to equal, again, 4a times 4a is 16a squared. Then we have the outside term. So 4a times negative 3b is negative 12ab. Then we also have the inside term. So negative 3b times 4a is negative 12 BA, but I'm just going to write it as AB, because you already multiplied, doesn't matter. And then the last one, negative 3b times negative 3b is positive 9b squared. And if you collect your like terms here, you get 16a squared minus 24ab plus 9b squared. Okay, so what you'll notice is that, yes, if you were to just, going back to this one here, if you were to just square the first term, second term, notice that you're actually going to be missing that middle term, right? If you just apply that. So that's why this is actually incorrect. You have to write it out twice. And expand, but I'm just going to write 4. So again, first outside, inside last. All right. So that's a very common mistake, is this one right here. So don't do that. Make sure you write it out twice, expand it out, collect your like terms. Right, cool. So in this third example, what you'll notice here is that I've got two terms here, but I also have two terms here. Two terms. Okay. I've got two terms here. Okay, I got two terms. Okay, it's not. Just for a second. All right, so let's try that again. So what you notice here is in the first one here, we have two terms. And three terms. Okay, there we go. All right, so in this case, in the previous two examples, we had 2 and 2. This time we have 2 and 3. Okay, so the key thing here when you're expanding out these brackets is, again, we're going to distribute, but this time the 2x must be multiplied with the 3 terms in the second one. And likewise, the negative 3 must get multiplied with the 3 terms in there. So you're actually going to get a total of 6. Right? So basically each one of these terms got to get matched up with each one of the terms in this next bracket. All right, so if you follow this, we're going to multiply 2x with each one of these three here. So that's going to be 2x times x squared is 2x cubed. And then 2x times negative 4x is negative 8x squared. 2x times 3 is positive 6x. Okay, so we get these first three terms here. We're multiplying the 2x with each one of these terms, the second set of brackets. And then what we need to do next is we need to multiply the negative 3 with these three terms as well. So negative 3 times x squared is negative 3x squared. And then we have negative 3 times negative 4x is positive 12x. And then negative 3 times positive 3 is negative 9. All right, so once we've expanded this out, we can actually collect our like terms. So the negative 8x squared, or the negative 3x squared, those are like terms. 6x with the 12x are also like terms. The other two here, the 2x cubed, you're going to leave it by itself. So that's 2x cubed. If I write this out, 2x cubed minus, let's put these two together here, so minus 11x squared And then these two here. So that's 6x plus 12x is 18x. And we have minus 9. Okay, so that is now this, the expansion of this simplified. All right. Cool, guys. So that is, yeah. So that is multiplying polynomials, part 1.